Thank you. Good afternoon, everyone. It has definitely been an interesting lineup so far. Quick question. Who here has tried to run a query on production, or you're trying to make use of a website and it's slow? It's not always our network, but you're using a query and it's slow. Anyone? Thank you. Yeah, me too. And every time we see that spinning wheel comes up, we lose our customers' trust each time. So we're talking about database, right? And the truth is, the database is like the engine room of our application, and a slow database is the single biggest bottleneck of your application, right? My name is Temitope, and today we're going to fix our database issues. We're going to dive into the fundamentals of database, which is indexing, go into query tuning, and how to scale our database engine. I like to make use of this analogy of thinking of my database like a library. Imagine you're a user going to the library and you're trying to look for a book, say, advanced database something. I mean, at the end of the day, nobody would look for something like that. Let's say popular hibiscus, because that's more interesting, right? And you go into the database, you go into the library, you're trying to look for a book. The truth is, the book in the database or in the library are like your user's data, right? What you're trying to search for. The card catalogs you see, those are like your indexes. Your users search saying, hey, give me popular hibiscus. That's more like your query execution. And the size of your library is your database capacity. Or let me even just bring it downwards, right? Say you're going to like a supermarket, right? You see those tabs up above that always tells you this place for toiletries, that place for that. That's more like an indexing to me, right? Imagine everything is just scattered there, and you're just going, you see toiletries here, you see something close to toiletries in another place. It will definitely take our time, right? So it makes it difficult for us to search. I'm going to come back to the analogy of using the library as your database capacity soon. So, why do our databases get slow? This is very interesting, right? First of all, which is the most common? Indexing. Does anyone know what indexes are? Anyone? No one? Okay, we'll get there. So indexes, most of the time, are what makes our database slow. Other times, bad queries. It's not necessarily like you don't have index. It's probably like saying you go to a database or a library and you're like, hey, give me a dusty popular hibiscus. Sometimes what you ask for is sometimes inefficient, which doesn't necessarily help. At times, it's too much data, right? You're outgrowing your hardware, which means your library is too small for the amount of books that you actually have. Other times, it's lock contention. Imagine your library has just one popular hibiscus, and everybody wants to read popular hibiscus, which means you need to wait for the person reading this popular hibiscus to return it before you use the next one. I don't think that's very efficient. It's going to take a lot of time. Another time, missing statistics. Your database just makes poor decision, but we'll come back to this also. So, indexing, right? I think a lot of people were a bit confused on that, so I would explain that shortly. So, an index is like a data structure that helps improve your databases or helps improve your queries speed. Has anyone here made use of any SQL? SQL, yeah. MySQL, Postgres, any one of them, right? When you mostly use like relational databases, they all have something called index. So an index is like an additional data structure, aside from your table, that helps you store things in a sorted way. So when you're looking for something, right, say you have an index on a particular column, let's call it username, right? My name is Temi, someone's name is Tolu, right? It's very much ordered, and Tolu is on a separate data structure. So when I tell the database, hey, give me everyone whose name is Tolu, the fact that that column is indexed, it first goes to the other data structure where I have Tolu, fetches all the Tolus, and it always holds a reference to the ID, right? And it goes to the main database to fetch it. That way it's faster. Instead of having to go through every single person here and asking, who's Tolu, who's Tolu, who's Tolu, your index helps you make that easier. But there's a catch, right? While indexes help you read your database faster, it also makes your write operation slower. Because every time you create a new Tolu, right? Sorry, is anyone here Tolu? Just in case. Because every time you create a new Tolu, it has to write it into your main DB, then it has to go into your sorted list somewhere to insert Tolu, so that every time you fetch a Tolu, it makes it easier, right? So yeah, faster reads, slower writes. Writes in this sense could mean insert operations, update operations, or delete operations. These are the downfalls of indexes. So it's very much important that you make sure that the columns you're indexing, you really need to. Another thing is extra storage, right? Like I mentioned, an index is an additional data structure that helps you keep things so you can query your database faster. So what are the types of indexes we have? The most popular one, the common one we use, are B-tree indexes. This is generally great for all purpose. It's good for grouping, filters. I mean, we all have every time when we log into like a website and there's a paged, right? Or let's say you're looking at your transaction history and you want to filter by date, right? Imagine if you're trying to filter for transactions done yesterday. Say you're a business owner and you have a lot of money, you're doing a lot of things. And it's so difficult for you to just search for things that were done last week. In that case, it might be better for you to have an index on that column. So a B-tree could help. Another kind of index that we have is hash index. This is super fast for exact matches, where you say something like, where name equals to Temi. Let me use my name. Sorry, Tolu. Another kind of index we have is composite index, right? So on your database, we all know we have, for relational databases, actually, I want to think we're mostly familiar for the engineers here or anyone. I feel like everyone mostly makes use of databases, right, aside for engineers. So this database helps you to have indexes on multiple columns. Instead of saying, oh, let's assume we want to filter by users, right, and everyone has first name and last name. Most people do. You could have an index on first name and last name so that your search query is faster instead of first name. In this case, a composite index works. Covering indexes also contains all data needed for a query. For instance, you can have an index on something that says where name equals to Temi, as simple as that, or a partial index. Sorry, that's partial index. So when should we add an index to a database? The do's. Columns in your where clause. For instance, where date equals to 20th of January. That's my birthday, by the way. Or columns in join conditions. For instance, you have two tables, right? You have a users table and you have an account table. But you want to find all of Temi's accounts, right? So let's say account is on users table, for instance. I'm just thinking out of my head here, right? And account is a foreign key, which is an external table. It's always good for you to have indexes on your foreign keys, because then if you don't, that's very expensive, right? You're just going to be joining things together and it could take forever. Imagine you have a database with like 10 million records. That's going to be very expensive. Other kinds are columns in order by or group by, and like I mentioned, foreign key columns. So when should we know you have indexes? If you have a small table, like less than 1,000 records, it's still going to be fast dataways. There's no need for an index, right? Because in that case, right, you're just going to be overloading, because by the time you're writing into the main table, you also have to write to the other table. That's very expensive. You don't need it. So only add indexes when you know that you have a lot of records on that table. So what are the best practices, right, for indexes? It's always better to start with your slowest queries, right? Check all the queries you have, put it on your slowest query. I'll go into something later that helps you know what queries are slow. Sometimes you can just tell yourself, when your users start coming back to tell you, this thing is taking forever, or you start losing your users, you know. or index column other matters in composite indexes. So there's this rule in composite indexes, right? Remember I said composite indexes are indexes on multiple columns. So there's this rule that says, oh, left to right, but stops at the first range, which means, say we have three columns in a composite index: first name, last name, and date. So it goes, if you do just last name, your index will most likely not work because it's ordered by first name, last name, and date. Then it's also important for you to monitor the usage columns used in index, consider your index size versus the benefit, and always update the statistics. Have like some monitoring tool somewhere, so you always check, right? Especially for redundant indexes. So query tuning, this is like the blueprints for your indexes, like the receipts, like what's actually happening, right? So how does your query execution plan work? Usually there's this thing, does anyone know, I mean, for people that use MySQL, Postgres, have you heard of explain keyword? Anyone? Okay, thank you. So explain keyword usually helps you know what's happening in your query. For me as an engineer, usually, when I start to write a complex query, my manager will tell me, yeah, Temi, drop the explain statistics or results of this query so that he will know if I'm cooking beans on production or this is actually good, right? So when you run explain queries and you see that it's a full table scan, yeah, that's very expensive. Sometimes your explain queries could also help you know where you should add your index. And when you see some like funny things within your estimated versus actual rows, you also know that there's something fishy somewhere. And there's also this thing I saw somewhere that helps you know what kind of columns to index. When you run an explain query, there's something called selectivity, right? It helps you know how selective this column is so that you know if an index will be good here or not. So common query problems. When you run select star, all of us do it. I'm sure we all do it. As long as you use MySQL, you always select everything. Select star, it always retrieves unnecessary data. Why are we selecting everything when all you want is just first name and last name? In this case, you're just loading excess thing. It's heavier, it's more expensive. Avoid it, please. Change that today. If you don't need everything and you just need some things, I think there are some ORMs or some languages that help you with projection and make these things easier, right? So you can look into that also. Another thing is M+1 queries. When you're running through loops, just to do something you can easily do. This is also expensive. There's a keyword called in. You can try that, run in queries, right? So implicit type conversions, preventing index use. So this one happens when, let's say you have a column of username, right? And on your DB, you just allow your username to be saved anyhow. But some databases are very specific, right? Say your username starts with small letter u, but by the time your user is coming, it's capital letter U they are passing. It's probably tell you it doesn't exist, right? So most times, some people probably want to first swap everything to uppercase, then do the comparison. I promise you, it's probably not user index. This thing happened to me once, right? I had a unique column, and I first turned everything to uppercase, and I was now searching by something. In this case, it's always probably better that you try to guard yourself, and maybe before you do your write operations, convert it. Or say you're searching by date, right? And you're now turning it into year first, instead of searching by the actual date range. That's bad. Another thing is missing join conditions, Cartesian product. Okay, so this is, say you want to find a username, an account, but you're not actually joining them by anything. You're just saying, oh, select star from users, join accounts. Where's the join column? You're not joining by anything. So in this sense, you're just creating 10 times of everything, basically. That's very bad. So what are the common query optimization techniques? Like I said, only select columns you need, use appropriate join types. If it's left join, right join, inner join. Does anyone know what the normal one is? Anyone? Thank you, thank you. So filter early, right? So you don't just do join and then you start filtering. Sometimes when you filter early, it makes your query more optimized because it just knows exactly what it's doing. Batch operations instead of using loops. Select name from users, where ID in, that works better. Also, making use of exist instead of count for existence check. Say you want to know if, let's say you want to create a user and username is unique, right? Instead of saying select count of users where username equals to Temi, what your database would actually do is count every one of them where username is this. In comparison to using exist, exist just checks that at least there's already one there. Once it finds the first one, it leaves, you get your result instead of running through everything. And avoid all conditions, use union. Or sometimes, or most often, will not make use of your index, but union will do this for you. So I have a query example here. Can anybody tell me what we could do better with this query? Anything? What do you think could be a problem? Sorry? Thank you, that's one. Anything else? Imagine you have 5 million records that could come in this, and you want to display a page to your user. What else could you do? Yeah, that's something. The date conversion. Something else? Thank you. So the problem is, select retrieves unnecessary data. Year function prevents your index use on the index because then you're converting the date into year. If there was an index there, it wouldn't use it. And status filter might not be selective, right? In this case, it might work, right? Because you probably just need things that fall into this bracket. Wow, my time is going. I thought I was going to be faster. Anyways, the optimized version, select specific columns, use range on index date, the way it is there. And limit to, your users you don't need to load all 5,000 for your users at once. Show them the first 100, you're good. Then you can fetch the next page. So scaling strategies, right? Now, sometimes the issue is not your index. You've probably done everything. Your indexes are good, it's running fine. But it gets to a point that your product is actually just doing really well, and you have way too many users. Your index will help you there. It's kind of like the analogy of the library. Imagine this library. You have a library that grows too big, right? And it can no longer take books. Obviously, you've done everything you can. What can you do? We have two things, vertical scaling and horizontal scaling. Vertical is scaling up, which is, say for instance, in your library, build like an annex or a gallery. Just find more space, or build a second-story building, right? So that is usually bigger, more powerful machine, bigger RAM, CPU, everything. It's very simple, no code changes. It's expensive, but hardware limited. What about horizontal scaling? In this sense, imagine if you don't make your library go bigger. What else can we do with our library? Thank you, another library, right? So that's scaling out. It's like the same database, but smaller replicated types. That also helps. So that's more machines working together, nearly unlimited scaling potential. It's more complex. It's like starting another foundation from scratch, basically. It's more complex, but works well also. Sorry, I think I pressed the wrong thing. Okay, yeah. So a very good example of scaling, of horizontal scaling, is read replicas, right? So it's like you have your main DB. That can do the write operations, but then you now have replicas of your main DB that does the read operations. So the primary DB handles write, replicas handle read. The downside is replication. Because it's asynchronous, right? Asynchronous means something isn't happening instantly. So by the time you're done writing, it needs to send it asynchronous to the other database. So sometimes there could be a bit of lag. So sharding is basically splitting your data across multiple databases. You could either do horizontal sharding, which is splitting by columns, or vertical sharding, splitting by columns, or horizontal sharding, splitting by records. But it is very important that you handle your shard key very well. Sorry, I need to go faster. So sometimes your database might still be slow. Imagine every time your user logs in, they need to show your picture. I don't think it's wise for you to go to the DB every time to fetch the base64 image. What else can we do? Thank you, we can cache. Redis is a very popular one, right? So for data that are frequently accessed and do not change often, caching is always very important, right? So you can cache the query result so that you avoid just calling your DB every time, calling your DB every time. However, when you're caching, it's also very important that you make sure that if the cache data is going to change, have strategy to invalidate your cache or update it accordingly. So this dramatically helps reduce your database load. So connection pooling is another thing. Always make sure to reuse database connections efficiently. Creating connections is expensive. And maintain pool that is ready to use. So monitoring and maintenance. This is something else that is very important. Has anyone heard of New Relic? New Relic, anyone? Okay, thank you. So it's very important. Most times people use it, right, to track their API speed. You could check it out, right? So it's kind of like distributed tracing, right? It could be used for different things. But most times, it also helps you know what APIs are running slow. And it is so detailed to the point that it shows you the span, that, oh, this is the point that it's slow. It's probably taking 3 seconds on this table, taking so seconds on that table. It really helps you point out the bottlenecks, right? So always monitor and check regularly, right? That always helps. So set up alerting for anomalies to know when something is slow. So quick win checklist. Index on frequently queried columns. Enable your logs. Implement connection pooling. Add cache for your hot data, right? You don't need to always fetch it. Then review and optimize your top 10 slowest queries. Please do that. Then schedule regular maintenance tasks. What else? So common pitfalls to avoid. Avoid over-indexing. You don't need to index all the columns on your database because they say indexes help things faster. Remember, like I said, for every single index you have, that's a new data it's storing somewhere. So imagine you have a table and you have 5 indexes. Once you write to that table, it also needs to write to those 5 other index data structures. It makes your write operation slow. Eventually, you start getting log timeouts because a lot of things are waiting to write. So premature optimization, don't always index. Sometimes wait, like we get it, right? Always just check, right? When you need the index, then you can put it. For instance, when you don't have a lot of users, you don't need it. So ignoring the query plan, it tells you everything. So always use explain, analyze. When you don't have monitoring, that's bad. So scaling without optimization, expensive band-aid. Resources and next steps. Like I said, explain, analyze. Database-specific documentation could also help you to understand better how your database works. I think sometimes I've also seen people try to add duplicate indexes. Do we know what primary keys are? Yeah. So most of the time, your primary key is most definitely always indexed because it's the primary key. But sometimes people still tend to go and add an additional index. It will still work. What's just happening is when that index works, it will write to the initial primary key index, which is usually the fastest, and still replicate it somewhere else. So please, please try to show the indexes on your table to know where the issue is. Analyze your queries to know, oh, is this index really important? Because it could actually be making your write operation slower. So please try to check all the indexes you have to be sure, and run explain analyze on your slow queries to know where the bottleneck is. It's your receipt. So thank you very much. And I want to say that if you're able to follow this, you're going to be very dangerous in all the right ways. So thank you. Any questions? Yeah.
It was an engaging session. So I see that you've covered RDMS, like the relational databases, but what advice do you have for us that sometimes use the NoSQLs, like Mongo, for example, and maybe, Cassandra, not whatever, but Mongo especially?
Okay. So to be honest with you, I've mostly worked with more of relational databases. I don't know, I kind of, probably the languages I've worked with, it makes it easier for you to have indexes because it's rows and columns, right? But I could check on that and let you know. Any more question? Anyone? Does anyone have question there? All right. Thank you very much.